Hello, my name is Catherine Kukunowa, a third semester student of chemical engineering at Exeter University. Today I will be talking about the topic of collisions for the subject of mechanical physics. Perfectly elastic collisions. They are those in which kinetic energy is not disappeared and is conserved. So if there is equality in the initial and the final quantities of motion, and if the kinetic energy is conserved at the beginning and in the end, we will be dealing with perfectly elastic collisions. An example of this is a billiard balls. Although their speeds are changed at the same time, when they collide, they lose a minimum amount of kinetic energy, which can be seen by the noise caused by the collision. A deduction of questions is carried out of the collisions. We have the questions for the initial kinetic energy of the system of particles, which must be equal to the final kinetic energy of the particle system. This is worked algebraically, where it is simplified and factored in such a way that it is shown that the initial relative velocity is equal to the final relative, and that in turn the velocities are used in the formula of coefficient of elastic restitution of the collisions. Two examples shown. First, ping pong that is dropped from a height, the ping pong falls down, hits the surface and returns to almost the same height. So if the race is of the same height, the coefficient of restitution will be 1. Second example is the truck that hits a wall. The coefficient of restitution will be 0 because the truck is stuck to the wall and it is not returned like the ping pong. In the case of frontal crashes, we can determine the value of the final speed using the coefficient of restitution E, which was proposed by Newton. It is concluded that depending on the value of the aforesaid coefficient of restitution, we can know the type of collision. For intermediate values between 0 and 1, we will be talking about a collision elastic where the momentum is conserved but the kinetic energy is not conserved. There is a certain loss of kinetic energy, which corresponds to the value of E. And this in turn, the closer it is to 1, the loss of kinetic energy will be less and tends to be an elastic collision. And if it approaches 1, the energy loss will be greater, so it tends to be a perfectly elastic collisions. Finally, we have perfectly inelastic collisions. In this, the maximum energy is disappeared and occurs when two particles merge and continue their merge as a single particle. Those mass is the same of the two original ones. For example, when a ball hits a block, the two rise together, and the bullet causing the block to rise a certain height.